Hi everybody. Alright, lesson 4 on solving algebraic equations. So in today's lesson what we're going to do is solve equations that are in this form right here. What you're going to notice is that there's an x value on both sides of the equal sign, so we're going to learn how to deal with those scenarios today. Now, the previous knowledge that's relevant for us in this information is from our polynomials unit. And in our polynomials unit, what you learned was that when you have an expression where you have x's and numbers, so 6x plus 5 plus 2x minus 1 minus 4x plus 3, what you learned was that the x's can be collected and then the numbers can be collected. So 6x and 2x and 4x, that's going to make 8 minus 4, so that's going to be 4x. And then 5 minus 1 plus 3 is going to make a positive 7. So because the x's can be collected together and the numbers can be collected together, we're going to use that as kind of like a frame of reference as we learn this new lesson. So in this first example, we have 1/3 times 2x minus 1 equals to 1/6 times 3x plus 1. And once again, you notice that there's x's on both sides. Now, one of the things you can do is you can distribute this 1/3 in. But instead of that, I'm actually going to try to get rid of the fractions first. So we can rewrite this equation as 2x minus 1 over 3 equals to 3x plus 1 over 6. And you'll recall that when we write fractions like this, we don't have to write the brackets. But when we write the fraction like this, 1/3 times 2x minus 1, you do need to write the brackets. Now, as it stands, we have this, and we have a common denominator of 3 and 6. So my LCD is equal to 6. So to get rid of both of these fractions, I'm going to multiply by 6 over 1 to both sides. So the 3 and the 6 will simplify, and then the 6 and the 6 will simplify. So now this part right here will be 2x minus 1 equals to 3x plus 1. And since these are 1s, we don't have to include a bracket here because we're not really multiplying by anything. Now we distribute. So this is going to be 4x minus 2 equals to 3x plus 1. All right, now when you get to this step, this is where we think to ourselves, all right, I have 4x on one side and 3x on the other, so I'm going to collect all the x's and then collect all the numbers. So first I'm going to move 3x to the left side of the equation, and to do that I'm going to subtract by 3x. So this is going to be 4x minus 3x minus 2 equals 2. This is going to be 0, so it's going to be 1. Then 4x minus 3x can be collected to make 1x minus 2 equals to 1, meaning x is equal to 3. So once again, when you're going through the algebraic steps, I'm showing as many steps as I feel is necessary. When you're actually doing the work and you, like let's say right here, 4x is minus 3x, you can simply say 4x minus 3x is x, and you can skip this step right here. Now, if I were to ask you to check this equation, what you would have to do is take the 3 and substitute it into both sides of the equal sign. So I would say the left side of the equal sign has 1/3 2x minus 1. If I substitute 3 into there, this is going to be 2 times 3 minus 1, which will be 1/3 times 6 minus 1, which is going to be 5 over 3. Okay, so that's the left side of the equal sign. Now on the right side, we're hoping to see the same fraction. So we're going to take our 3 and we're going to substitute it into the variable there. 3 times 3 plus 1, so 1 over 6. This is going to make 9 plus 1, which is 10, leaving me with 1 over 6 times 10 over 1, which will be 10 over 6, which reduces down to 5 over 3. So these two sides are equal, meaning we are happy. Okay, this next example should feel very familiar because it was the last question on your most recent math test. So I'm really hoping right now that everyone has written the math test. If not, you get a free question. So a cell phone data plan costs $17.50 plus $2 per gigabyte used. A second cell phone plan has no initial cost but costs $3.50 per gigabyte. Now, on the math test, what I had you do with this question was I had you start somewhere and then sketch a graph, and then the second equation was graphed like this, and we were looking for this position right here, and then from there you could tell me, oh, how many megabytes would you use before it costs the same. Now what we're going to do is we're going to solve this but using an algebraic approach. So we're going to create two equations here. First, we're going to say, well, let x represent my gigabytes. It's going to represent the number of gigabytes used. And then we have two cell phone plans. So plan A and plan B. And what we're going to do is we're going to try to create equations for both of them. So my first cell phone plan is going to be $17.50 plus $2 per gigabyte. Now we've had a lot of practice with this, so what we know is that it's going to be 2x plus 17.5. That's going to be plan A. My second plan has no initial cost, so the initial cost is going to be 0, just like 17.5, and then the $3.50 is per gigabyte. So that's going to be $3.50 per gigabyte. Now, since I want to figure out when they equal, so like this point right here is really asking the question, when are they the same? So what I would do in this scenario is I would say, oh, I want to figure out when 2x plus 17.5 is equal to $3.50 of x. So what we're saying is we're asking the question, when does plan A equal plan B? Now I've set up my equation, so that means I can then work to solve it. Now, since I can see that 2 is smaller than 3.5, I'm actually going to move 2 to the other side. So I'm going to subtract 2x from both sides, leaving me with 17.5 equals 2, and then 3.5 minus $2 is going to be $1.50. And then from here we divide by 1.5. So divide by 1.5 divided by 1.5, giving me a value of 11.67. So it's not a perfect number, but that's okay. What we have to do is write a sentence that makes us understand that this question makes sense. So it's saying, when will it be equivalent? It will be equivalent when you used 11.67 gigabytes of data. When you use 11.67 gigabytes of data. Okay, so just to summarize, today's lesson is what do we do when we see x's on both sides of the equation, and the summary is that we have to collect them onto one side before solving for x. Okay, try these two on your own, and then I'll see you tomorrow.